In an area 10 miles from downtown Denver, there exists a zone where, for more than 80 years, any living creature that entered faced the risk of being completely destroyed. This was once a place that produced industrial chemicals, VX nerve agent, and napalm bombs toxins capable of wiping out life across an entire continent in only a few hours. The soil here was so polluted that the United States government had to spend up to $2.1 billion just to prevent the toxic agents from spreading. Every environmental expert at the time confirmed this would be a biological dead zone that could not recover for hundreds of years. And yet, every prediction was overturned in 1989 when a population of more than 700 prairie dogs was introduced right into the center of this polluted zone. This was considered an extremely risky experiment, but instead of being completely wiped out, they began a process of re-establishing the ecosystem. They dug, altered the chemical structures in the soil, and directly restored the foundation of life without human intervention. This very tunnel system encouraged the return of bison, eagles, and even some of the rarest predatory mammals in North America, right on the land that had once been a chemical weapons arsenal of World War II. So how could a rodent weighing less than 1 kilogram fix a billion-dollar pollution disaster? What really happened beneath those hazardous material storage bunkers? Everything began in 1942, right after the Pearl Harbor attack. The United States military needed a place far enough inland to produce chemical weapons where enemy bombers could not reach. They chose Commerce City, Colorado. Hundreds of farming households were relocated from the area. Wheat fields were cleared to build production complexes for incendiary agents and white phosphorus. When the war ended, the plant did not stop. Shell Oil leased these facilities to produce high-concentration pesticides. For 30 years, millions of gallons of liquid waste were poured directly into unlined dirt trenches. A storage pond called Basin F, covering 93 acres, held more than 200 million gallons of highly concentrated toxic sludge. In 1961, to handle the waste, the military drilled a well 3,600 meters deep and pumped 165 million gallons of hazardous liquid underground, under extremely high pressure. Immediately, Denver, a city with a stable geological structure, began recording earthquakes as strong as magnitude 5 on the Richter scale. Pressure from the liquid cracked ancient geological faults. The Derby faults were reactivated by the intrusion of this massive amount of wastewater, turning a chemical disaster into a large-scale geological crisis. Many people believe burial is an effective solution for chemical waste treatment, but when the geological layers shift, and the water source of 1.5 million residents is threatened, is that an engineering measure? Or just an exchange of future resources for short-term purposes? Leave your opinion in the comments section about underground hazardous waste management. Your responses are a valuable data source for preventing similar disasters. While the core of the arsenal was a heavily polluted area, the military security fence created an outcome no one expected. For more than 8 decades, thousands of acres in the buffer zone had no human presence at all. No farming, no agricultural pesticides, no expansion of the city of Denver. In 1986, scientists discovered a large population of bald eagles wintering here. This bird species requires an absolutely quiet environment and old-growth woody trees, which the arsenal's buffer zone had preserved intact. The presence of this rare bird ended land development plans from investors. However, the land at that time was only a degraded area. The topsoil layer had been scraped away by excavators to isolate contaminated zones. What remained was a flat, hard, and completely barren surface. Measurement data showed that soil compaction reached 95%, a level of compaction that prevented all gas exchange between the atmosphere and the underground. Rainwater could not penetrate more than 2 centimeters, turning the area into an inert surface, causing erosion and spreading pollutants through runoff. The ecosystem could not regenerate itself because the soil had lost the physical structure needed to hold water. This was the moment when 714 native creatures began carrying out their mission. As soon as they were released, they began breaking the paralysis of the system. The soil here was so compacted that rainwater could only run across the surface. The burrows of the prairie dogs created channels that carried water deep into the ground. A burrow system of an average prairie dog colony can extend up to 30 meters, with many complex side tunnels. When 714 individuals began working, they created dozens of kilometers of tunnels that pierced the rigid crust of the ground. With every digging movement, they brought minerals from deep below up to the surface, mixing them with dung and organic matter from plants. This process is called bioturbation. The openings they created allowed oxygen to penetrate the deeper soil layers, awakening microbial communities that had long been isolated. Detailed geochemical analyses show that organic matter content in areas with prairie dog burrows increased significantly thanks to the nutrient regeneration cycle. Nitrogen and phosphorus were converted into easily absorbable forms, helping local vegetation grow strongly without artificial intervention. This was the key factor in restoring areas that had once been heavily polluted by previous industrial activities. When it rained, water seeped down through the burrow channels instead of running across the surface. Average soil moisture increased from 12% to 28% after only a short period. This amount of water created a temperature-regulating mechanism, reducing the harshness of the environment and protecting plant root systems from high summer temperatures in Colorado. This change encouraged symbiotic fungi to reappear and develop. The microbial system and fungal networks, once damaged by chemicals, now began recovering thanks to new moisture conditions and nutrient sources. The process of biological decomposition was strongly accelerated. In particular, some activated native bacterial strains began breaking down residues of complex organic compounds, converting them into safe components through nature's self-cleaning mechanism. Prairie dogs have a strange habit of trimming all vegetation around their burrows down to just a few centimeters high so they can have a full 360-degree view to detect enemies. This action unintentionally creates an extremely rare shortgrass prairie environment. On a global scale, this is one of the ecosystems at the highest risk of disappearing. By keeping grass height low, prairie dogs created conditions for prairie plants to germinate because they received enough sunlight. This increased plant diversity and helped stabilize the structure of the entire topsoil layer across the region. This is a perfect symbiosis between animals and plants. Grass provides food, and the prairie dogs provide mowing services that keep the grass in its strongest growth state. This type of vegetation is much richer in protein than tall-growing weed species. From that point on, new species began migrating in. First came the burrowing owl. This small owl does not know how to dig burrows and depends entirely on abandoned prairie dog burrows for nesting. Observation data recorded that the survival rate of young owls here was more than 40% higher than in artificial nesting areas. Next came the mountain plover, a species that only settles on open ground cleared of vegetation. An important turning point came in 2007 when scientists reintroduced 16 bison into the area. Bison and prairie dogs have a long-standing ecological connection. With a weight of nearly 1 ton, bison hooves create microstructures on the ground surface that help retain seeds and water. Bison waste provides a major energy source for the microbial system that the prairie dog population had established. From the initial 16 individuals up to the present time, the bison herd has grown strongly to a scale of hundreds of individuals. The food chain has been fully restored. Birds of prey such as hawks and golden eagles have appeared regularly, forming a natural biological control system. The appearance of top-level predators is proof of an ecosystem that is gradually stabilizing. When falcons and hawks begin hunting, they maintain rodent populations at a balanced level, preventing the over-exploitation of plant resources. The area that once stored hazardous materials has now become a self-operating and sustainable system. When everything was progressing well, a biological challenge appeared: plague. This disease is caused by the bacterium Yersinia pestis and spreads through fleas on the bodies of prairie dogs. One outbreak can reduce 95% of the population in only a few weeks. Plague in prairie dogs is a systemic risk. If the prairie dog colony disappears, the entire burrow structure will degrade, water will no longer be able to seep down, and the surface soil layer will disappear. In the past, conservation areas often struggled to control this disease. But at Rocky Mountain, scientists applied a high-tech intervention strategy. To control biological risks, a modern protection system was established. Scientists developed a bait-form vaccine with a scent and flavor attractive to rodents. Instead of using manual methods, experts applied precision positioning technology to ensure that every burrow cluster received timely medical access. Since 2018, this process has been optimized with unmanned aerial vehicles. Autonomous devices are programmed to distribute thousands of vaccine units per hour along carefully calculated routes. This technology helps reduce costs and limits human presence, keeping the wild environment undisturbed. The bait pellets are integrated with fluorescent markers. This allows experts to check the immunity rate in the population using ultraviolet light without directly invading the animals. This is a combination of biotechnology and modern wildlife management. To date, the successful vaccination rate in key burrow clusters has reached more than 85%. As a result, while neighboring areas of Colorado still record scattered plague outbreaks, the population here continues to develop steadily. This is considered one of the most successful wildlife disease management projects in the world. All the efforts above aim toward one final goal, the most important test for the revival of this land. On October 5, 2015, the iron cages were opened, and a small creature with dark black eyes and dark-colored feet stepped out. It was the black-footed ferret, the rarest predatory mammal in North America. The black-footed ferret has very strict biological requirements, with prairie dogs as its main food source. The fact that they can survive and develop here is evidence confirming that the biomass source has become abundant enough and that the environment no longer contains toxic agents affecting the food chain. They serve as indicator individuals for the restoration quality of the entire system. To date, the black-footed ferret population at Rocky Mountain has sustained itself through more than a decade of natural reproduction in the wild. This is a record figure for an area once considered degraded land. Scientists have discovered that they are migrating into neighboring lands, beginning the journey of reclaiming lost prairies. This area has now become one of the most important urban nature reserves in the United States. With more than 330 species, it is not only a center of biodiversity, but also contributes major value to the local economy through ecotourism activities. Every year, thousands of people come to witness the revival of life on land once destroyed. The location of the reserve right beside modern urban structures creates an impressive contrast. This coexistence sends a powerful message about nature's ability to recover. When humans apply the right remediation measures and give nature space to self-adjust, life will always find a way to return. The story of the Rocky Mountain Arsenal has taught humanity an important lesson. We can negatively affect nature with giant machines and complex chemicals, but to heal it, sometimes we only need the smallest living creatures. Real-world results show that the impact of small organisms is far more effective than large-scale engineering projects. They carried out a natural biological restoration process without needing complex equipment. This miracle not only revived a piece of land, but also strengthened faith in the planet's powerful ability to heal itself. The barriers and danger warnings of the past have now been replaced by a green prairie and biodiversity. The transformation from a polluted zone into a healthy ecosystem shows that nature always has solutions if humans know how to respect and support natural laws. If you believe that nature always has a way to heal itself when humans know how to take one step back, hit like and subscribe to the channel so you do not miss other miraculous revival journeys on our planet. Thank you for accompanying us.